Thank you. So, if you've got any more comments about this slide, that would be great to have. I totally believe that he's right, that as scientists, we know that we create hypotheses and then test them out. I regard teaching, in a sense, as a hypothesis of what's the best way to engender learning. That is really what we're doing, is trying to create the right atmosphere and environment so that students learn. So in a sense, any kind of assessment is as much about what you've done as it is about your students. And I think that perspective is important to avoid one of the misconceptions or myths that we put into our advertisement for this webinar, which is to do with students' ability. And getting too hooked on students' ability, I think, is a mistake. And assessment can help us go beyond those kind of fixed ideas and improve learning as a result. So here is what you're going to take away from today. There are 3 principles we're going to argue for and put into practice. The first one is to look at tests, which is probably what you use most for assessment, and to think, how can we get more out of them? How can they show us progress better? Second, let's look a bit further back in our teaching. Instead of waiting till everything's all over and just measuring what students have learned, maybe if we're trying to improve teaching, we should be looking somewhere in the middle of the teaching sequence to figure out, are students getting it? So that we have some time if they're not. And thirdly, as I've suggested, it's not just about knowledge, and ability isn't something that we can take as a fixed quantity. We should be looking to improve it. That's what mastery is all about. And we have some ideas about how you can do that. I hope that sounds like an interesting agenda. Gemma's on the chat, so if you have any questions about this, or if you've been doing this yourself and you'd like to share what you've learned, please tell. So here is the first section, and this concept of alignment, which we believe in rather strongly. So Blueprint, in a sense, is the alternative to what many schools have slipped into, which is teaching to the specification. You know, GCSE appears to be the goal, so we look at what's in the spec and we just cover it and think, well, that's the job done. Now, I'm sure you being here, you don't fall for that. So you know that teaching to the spec is a great way to get all the content covered and AO1 kind of knowledge grasped, but it may not be so good when it comes to the other assessment objectives, AO2 and AO3, which in recent years, of course, have become more prominent. In the old days, when AO1 was ruled the roost, you could get away with not worrying too much about whether students were able to apply or analyze knowledge, but that's no longer the case. And it's a fact that many students don't seem to learn how to do that, and we need to work on it. It's also a fact that those kinds of capabilities were put in place by the government because the jobs of the future, or even the present, are going to require the ability to work with knowledge rather than just recall it. So it makes sense to aim your curriculum at all the assessment objectives. And we're going to talk about how to do that very briefly. This idea of alignment, pretty obviously, means working towards the overall purpose and making decisions that are consistent with that. It sounds easy, but it is actually quite hard, because a lot of the decisions that we make in schools are not really consistent with the overall mission and purpose. So that's the theory, at least. And we can help you a little bit, because at the top there is this idea that the curriculum is a kind of learning progression from the students who come in being novices at science, and we want them to leave relatively as experts. That's what we've been saying in all the webinars, and that's the purpose of Blueprint, is to provide you with a kind of progression from novice to expert. And then below that, the box, key concept goals, we've worked on trying to create a concept level progression within each concept, setting out more specific goals of what students need to achieve. So once the goals are in place, the next question is, how do we know if students are meeting them? And that is the purpose of assessment. So that's the topic of today. Just to recap, I do want you to think of the curriculum map in Blueprint not as just a, topic list. This is what I put in each year, because obviously you have one of those already. This one has been designed to be a learning progression. In other words, what we've done is we've identified the biggest ideas, and within each one we've created a progression of key concepts. In other words, what we want students to master at each year. So if you took one example, let's say forces predict motion, here is a rough sort of progression from what students know when they come in at primary school, hopefully, and then how that builds up through a number of concepts that over time we want them to connect and integrate together so they really get an understanding of this big idea. And it's the connections between their ideas that typify how an expert thinks, whereas having lots of disconnected ideas is what a novice has. And that difference, as we've previously explained, influences whether students can solve new problems and apply knowledge or not. And then within each key concept, we have created a progression in the planners that you may have downloaded for Blueprint. There's a progression of stages, starting with activate. It's too small to read, I know, but you may have got this printed out already for yourselves. Activate to analyze, we'll go into more detail later, is a learning progression within each concept. So the backdrop to the assessment is, what are the goals we're trying to achieve with our teaching? And we've broken them down into quite small, precise steps. Time to present myth number one, which I advertised probably in a newsletter you may have read, which is the belief that seems to be out there that unit test scores are the things, that we need to look at. That's really our currency of assessment. They are certainly the easiest things to get, but are they useful enough for our purpose? Remember, our purpose is to see if students are making the maximum progress and whether our teaching is working. So you can put together tests, right? But think carefully about what you're doing when you do that. You're often probably getting questions from a number of sources. You're finding that, well, there's only one or two on this particular topic. And so I just have to take what there is, put it into some form, and hope that what it's actually measuring is what I want it to. But very often, it may not be. So that the score you get at the end of it may not show you enough about what that students really understand, or more importantly, where they didn't understand. So that score doesn't necessarily mean very much. A better kind of output would be to show for the class, I'm sorry this is small, how well they're doing on each of the AOs, seeing as they are the objectives that are going to be assessed on GCSE. and being able to track how the performance of the class changes over each term, let's say, during your 5 years. If you could do that, you might see where they're falling down or what needs more time. And you could then look at each key concept. If you had the right questions, you could look concept by concept and see where the weaknesses are. And again, you could look at the individual and see where their strengths and weaknesses are to find targets for them. But to do that, of course, you need tests that are well designed. And designing a test like that isn't something that is necessarily easy or something that you already have. So my first question, as we pause here, is, do you have tests in existence already that measure the type and the depth of knowledge that we think you need to be assessing to see if progress is occurring? How about you answer that in the chat? Do you have these kinds of tests that can give you these kinds of graphs already? Okay, only a few comments coming in, but I haven't heard anyone yet say yes, they do. If you all said yes, we do, then perhaps we wouldn't need the next section. So I was hoping you would say no. Otherwise, Gemma can just go home. What do we think, Gemma? Do we think there's enough reason to talk about making tests better?
I think so, because they are quite difficult to do them like this. And I think a lot of, if you buy tests ready-made, then they wouldn't be set out the different AOs, not at Key Stage 3 anyway.
Absolutely. We have some comments that say, well, past papers could be adapted. What do we think about that? Do you think for a year 7 that you can adapt GCSE past papers to provide specific information on each key concept at each AO level? What do you think, Gemma?
No. Not normally, just because GCSE questions are not really suitable for year 7. Sometimes the content is okay, with a little bit of tweaking here and there, but just the literacy demands probably be too high for year 7.
That's right. I think it's possible in theory, but I think just taking from existing sources, you find it quite difficult to do that without considerable adaptation if you want to be precise about each key concept, each AO, and make the level appropriate. So given that you're going to have to do that sort of adaptation, Gemma, how about let's talk about how to do it?
Okay. So I'm going to show you then how you could construct or adapt one of your tests that's going to not just give you an overall score for your students, but also is going to give you an indication of how well they're doing on each of those AOs as well. So this is what we, oh, sorry. So what we're saying then is that the end of a unit or the end of a key concept, we're going to give a summative assessment, but we're going to make sure we're assessing the AO 1, 2 and 3, science ideas, plus we're also going to be assessing inquiry, which is something that a lot of tests don't currently do. And it's a good idea to get them in the same proportion as GCSE. So some AO 1, some 2 and some 3 in the same proportions as you would get in a GCSE paper. So this is based on what we've done for one of our tests on one key concept called cell structure. So I'm going to show you what we've done, and then it's quite easy for you to adapt a test in the same kind of way. So what we do is we start off with some low demand questions, which are testing AO1 knowledge. So AO1 is facts, recall and understanding. So for the first few questions, we're just going to assess facts and recall. So low demand. Also, we're going to stick with low demand in literacy. So they're going to be tick boxes, one-word answers, drawing lines to match things, those kinds of questions. The reason for that is we want students to build confidence. We don't want to give them really tricky questions at the start. So we're going to start nice and easily so they're confident and they're happy to continue with the test. And we're going to make sure we test each main idea. So basing it on Blueprint, cell structure's got two main ideas. So we need to make sure we test each of those. So this question is testing one of those, which is cell function. Now, AO1 isn't just recall, it's also testing understanding. So that's a little bit more demanding. So we're going to have some questions that assess the understanding of these main ideas. And that's an example of one of those. And we're also going to have some apply questions. So those are the AO2 questions. So this is an unfamiliar situation and we're getting students to use problem solving. So not just recalling, they're going to have to use their information that they know to solve a problem. And in Blueprint, we've got the apply statements there, which show you the kinds of questions that students are going to have to answer for apply. And we also have questions that test the inquiry skills and also any techniques that might be in that key concept. So in cell structure, the students will be learning how to use a light microscope. So you can put questions about that as well, AO1 and AO2 into your test to make sure that they understand that. And also you will need AO3 questions. So not very many because there's not many AO3 questions in a GCSE. Remember what I said about the proportion. So we only have one AO3 question in our tests. So these are questions which are going to ask students to analyse information and ideas. And we've put in understanding of a science idea and also linked to a skill as well in those questions. So they're worth 3 marks and they require a longer answer. So we're upping the literacy demand in those AO3 questions as well. So that would be the last question, the hardest one that they come to at the end. So if you do this kind of test, then there is the opportunity then to actually have a look at each student and how well they did on each of those AOs, as well as how well they did on inquiry compared to science knowledge. There's a lot of different data that you can get from one test, and that will allow you then to make changes in the way you teach. So, for example, you might detect that students aren't doing so well on AO1, the recall and the understanding. Now, that might mean that those students need to relearn that topic. It might be a topic that they're finding particularly difficult. When you get to assessing year 9 to 11, you might want to think about putting on revision classes, which you probably do already with GCSE students, but it will help you to focus on what exactly they're finding difficult that you might need to go over again in those revision classes. If they're not doing very well on AO2, then they're obviously missing those strategies for problem solving. So that's something that you can teach in the lesson. We have our mastery practice books that show you a strategy on how to problem solve, so they can use those to help them improve their AO2. And if it's AO3, then they obviously need more targeted help with those kinds of questions. So we're looking at improving their metacognitive strategies on how to answer those AO3. So you might want to model in the classroom how you would go about breaking down an AO3 question and how you would answer that. Poor inquiry, then next time you teach inquiry in the lesson, or next time you have a lesson which involves inquiry, take more time to actually teach them how to do that skill and model that skill. And we talked about in the last webinar how you can teach inquiry in the lesson, so some strategies that you can use to do that. However, as this test comes at the end of a unit, then it would be better if you knew about how they're doing on each of these areas a bit earlier. So Tony's going to talk about how that might be possible. Okay.
Thank you. So I'm going to introduce a new concept here, which I think is quite useful when it comes to your assessment thinking. Let's start with this idea of a learning progression. What we're trying to do, of course, is break down understanding into smaller steps. So within one key concept, we have provided a goal and a number of these stages, one stage, one goal, so that you can see how to get from students who are coming in on the left with some prior knowledge and take them towards the right so that they can actually do apply and analyze questions. And we see this as a 5-stage process, and that students kind of hop along these stages, and as they do, they develop the knowledge and understanding and the ability to apply and analyze it. So why is that necessary that we use these stages? Because if you wait until the unit test at the end, all you're doing is finding out whether they've mastered it or not. There's no more time really to do something about it. What we really need to do is to get into these earlier stages and find out how things are going, monitor how this understanding is developing so that we can actually change course during the teaching of a concept. There is a technical word here which is worth learning, this idea of an indicator. And it comes from economics, so I'm going to give you the context first and then we'll apply it to learning. So in economics, they tend to measure two kinds of things. The easy kind is called a lagging indicator. So gross domestic product, the result of all the economic activity. You know, I'm not an economist, but you get the gist that this is the output that we're measuring. This is the black line. This tells us the result. But when the result has happened, it's not so easy to do anything about it. Hence, other kind of indicators that are predictors of what's going to happen are more useful. So one of these is consumer confidence. And so economists measure this as a signal that GDP will change in response after an interval. So it's really useful to know these things earlier, because if you can predict, then you might be able to change it and make some actions. So the idea is that we want leading indicators, things that happen before the result, things that we can control to some extent by our actions, and things that have some powerful influence over the result. These are leading indicators. And obviously the test is our lagging indicator. So leading indicators, as I've mentioned, would be things that take place in the learning stages before you've got to the end, before you measure the test score. It is possible to think about a leading indicator for each stage. So I've put 3 here on this picture. The activate stage, many people were commenting at the beginning on this tricky problem that students turn up in year 7 not knowing the things that you'd hoped, and so you have to actually start teaching at a lower level. This stage here, if a large percentage of students are missing the prior ideas, that's very important as a leading indicator that they're not likely, all things being equal, to master the new key concept, unless of course you were able to reteach those missing prior ideas. They have little to build on. They're not likely to have mastered the learning at the end. So activate is a good leading indicator of future progress. It's also something you can do something about. Similarly, in the acquire, this is the main stage of learning. If you do something like having exit tickets after the lesson on the key concept, you can see whether students are grasping what you've just taught them, if you design them well, and that will tell you whether they need more time or whether you can go on to the next stage. So knowing that, of course, allows you to act and it allows you to influence the result rather than wait for it to happen. But we're going to focus on the assess stage. We've covered the 2 first stages in previous webinars, but now we're going to look at the diagnostic quiz as a leading indicator that will tell you what students' understanding is likely to be in that unit test if you don't do anything more about it. And of course, the intention is that knowing the information means that we can do something about it. I've also put down at the bottom, just to show you that it's not a small area, but a massive kind of set of possibilities if you want to find these leading indicators, that researchers for decades used to measure something called academic engaged time, how much students were engaged on doing productive work on things that they were having a moderate amount or high amount of success on. And that was a top predictor of their learning. So there are lots of ways we can look at learning in action so that we can take some steps to improve it. But of course, you can only take those steps if you have the learning progression in place, which is why I hope Blueprint will be helpful, because we've set out the goals for each stage and set out what the understanding is. Gemma, any questions before we continue?
Just a general question about if we've missed previous webinars, where can they be watched?
They are on YouTube and the links are on the webpage, which I will send to you in a second.
Okay, thank you. Right, so we're going to have a look at what we call diagnostic quizzes that are going to be used in the assess stage, so after the acquire. And they've got lots of uses, both for teachers and for students. So for teachers, it's showing you if your students have got a good understanding of the main idea. So they're not just testing recall, they're really testing understanding. They're also going to highlight any specific misconceptions your students have got, so you know what those are and you know how to correct them before you move on. And it's used as a tool to give you an outcome of how you're going to guide the next lesson. So you will find that some students are ready to go on to the apply stage and others need to go a different route, and I'll quickly go through that in a minute. For students, obviously, you're giving them some retrieval practice because they're going to have to try and remember what they already know. And we know that by doing that, that's actually helping to embed that knowledge into their long-term memory. Giving them an opportunity to improve their thinking skills because, as I said, these questions are not straight recall. They do require quite a lot of thinking. And they're actually going to be marking their own questions. So they're getting feedback there, having a look where they went wrong and why, which is giving them an opportunity for further learning. So lots of good reasons to use a diagnostic quiz. So if we look at the cell structure, again, this key concept, this diagnostic quiz is going to help us to test that main idea. So cells use energy to carry out life processes like growth and reproduction, and they have specific parts for these jobs. So that's one of the main ideas these diagnostic questions are going to help assess. So this is a typical quiz, which has been labelled as a diagnostic quiz that we've found. It's not a diagnostic quiz. I don't know if you can see why. Have a quick look at those questions. So it's covering that main idea that I just said about cell parts and their functions, but it's basically really just recall. It's not really testing that main idea if they've got that understanding about the link between the part and its role in the cell life processes. So it's basically just, what is this part? What is its function? It's also not really trying to reveal any kind of misconceptions that students have. So mostly you're going to get quizzes like this because they're really easy to write, and diagnostic questions are difficult to write. I'm going to give you a few little hints on tips on how you could do them though. So first of all then, you want to make sure you know what exactly you are assessing. So this is all in Blueprint for you. We've got the concepts there, we've got the two main ideas from cell structure, and we've got the apply statements, which are also on Blueprint. So you know those are the things that you can assess. We've also got misconceptions. So we've got a list of misconceptions that we want to test as well. So what we're going to do is we're going to try and get in questions on the concept. So each one is tested at least twice, really, because you want to make sure that you've got nice reliable data. So you're going to test each one at least twice. And again, with the misconceptions, make sure you test each one of those. So when you've done that and you know what your questions have got to be like, you can write your diagnostic questions. So we've got two here, and we're testing two misconceptions here. So the first misconception is that cells don't contain water. So we've got, on the first question, we've got two distractors there that students might select. And if they select them, then that tells us they've got this misconception. And the second question there, we're testing the misconception that cells are like the model. So they're using the wrong model there. So we're testing that misconception. We're also making sure students don't have, they don't think that the nucleus is the brain of the cell. That's something that some students pick up from somewhere, and they often say that. And it's important that they don't think that cells have got brains, because obviously that's going to give them a lot of confusion later on when we look at the hierarchy in terms of cells, tissues and organs, and the size of cells compared to other structures. So we're testing that they don't have that misunderstanding as well. So you can see that these diagnostic questions have been designed then so the distractors actually show you something about what the students know or they don't know. As I said before, it's a really good opportunity now for your students to actually mark their own questions. So we've supplied this feedback sheet, which tells them if they got the correct answer, why is that correct? If they got the wrong answer, why is that incorrect? So by marking their questions, they're actually learning some more and understanding where they went wrong and why. And then the next stage, so if they've significantly mastered that key concept, and we're recommending that by mastered, we're saying about 75% correct on the test, then they can go on to the next stage, which is applying their knowledge. If they don't pass that threshold, then they go into another stage called the rethink stage, where they're going to look over those main ideas again in a different way as when you taught it in the acquire. And then they have another opportunity to do the test again, but it's a slightly different test this time called the reassess. And then when they've done that, then they're ready to move on to the apply. And in the apply, they're going to solve some unfamiliar problems. So here we're going to have a class split and doing different things at different times. That's obviously a classroom management issue. So there are different ways you can get around that. You can have students doing different things in different groups. The students doing the apply might be able to work more independently, and you might want to spend more time with the students doing the rethink. So this is an example of a rethink. It could be lots of different types of activities. We haven't supplied these in our mastery materials because we think you've probably got quite a lot of different resources that you could use for rethink. So it can be a self-study thing, it can be through peer tutoring, it can be one-to-one with a teacher, so you can have a group that you go through the rethink with. Whatever material you use, it needs to address those misconceptions because they're going to stop students from progressing. It's best if it shows the idea very simply, step by step, and breaking it down. And it's giving students immediate practice as well. Straight after, we've got some very simple questions for them to test their understanding. So as I said before, when they've done the rethink, then they can go on to do the reassess, which is a different version of the assess. So it's testing the same types of things, but it's a slightly different question, so they can't just remember what it was the first time round. So that we're giving them another opportunity to do a quiz, and again, reinforcing that knowledge with that retrieval practice. That's the end of that section. Is there any questions?
I've been answering a few. I was going to pose one to the audience about reassess, because I think that is something that is not in common practice. Do we think that this opportunity to redo the test a second time to show that you've actually improved, taken on board the feedback, reconceptualized your thinking maybe, is that valuable? And would you make time for it? How would you do it? Something worth chatting about. Notice that we've given you a kind of flowchart for what to do after the assessment. This is the assess stage, and it leads into the next stage, apply. I said before that you can use other early indicators to monitor understanding as it develops. You could apply this same flowchart to the activate stage. You can give students some pre-assessment, and if they didn't have the prior understanding, you can do the rethinking before you move on to the new knowledge. And we would recommend that too. And in the same way, you could do the same thing with acquire to decide whether they've grasped the main idea or they actually need more exposure, let's say, to the phenomena and to the basic ideas and the models that you've introduced before you go on to practice it on a worksheet. So this kind of idea of monitoring and then acting depending on whether enough students have got it or not is what we think you can do with these early leading indicators. And of course, it's an investment, isn't it? Instead of just measuring what's already happened, you're taking control and going, I can actually make that better. And then you can see the results later. So let's move on to abilities. I posed this as a myth in the adverts, that it is almost as though we believe it's enough to assess knowledge, right? GCSE questions are basically looking at knowledge. So as we use those to make our tests, we do the same. But of course, to do well in GCSE, you need more than knowledge, right? So what's in the statements is only the visible part. AO2 and AO3, as we've argued many times and is coming up again in the next webinar, requires cognitive strategies, metacognition, literacy. So actually, there's a lot beyond what's written in the statements. And these kind of abilities are there, but they are invisible. So you can imagine that academic performance, which is what the GCSE is measuring, is actually a combination of knowledge on the left and abilities on the right. And all of these have been absolutely proven to be important factors in achievement. So scientific thinking or scientific reasoning, how you combine the ideas with the evidence and inquiry skills, something we dealt with in the last webinar, that would determine whether students can make sense of the new situations that come up in AO2 questions, for instance. The metacognition would determine whether they can make a plan with multiple sources of information in an AO3 question, or organize an answer which has to be set out as an argument. And then, of course, there are lots of factors, as you well know, that are not cognitive, and these are called non-cognitive factors, like a student's attitude, students' academic orientation, whether they are kind of a incremental mindset rather than believing that their intelligence is fixed. all of these factors affect how well students learn in the long term, how much effort they put into their learning, and whether they're confident enough to tackle difficult, challenging questions. So this has maybe a more indirect, but still very strong influence on academic performance. So when you measure a test result, you are actually measuring indirectly all these knowledges and abilities. The trouble is, of course, if you only look for knowledge scores and you don't really pull out any of these abilities, then you can't really do anything about them. We all know that saying, what gets measured gets managed. And if we just look at knowledge scores, then it's as if we're thinking students have a fixed ability and it's the same from when they come in. You know, we measure their cognitive ability, we put them in some group based on that, and they kind of keep the same ability in the 5 years. Now, the trouble is, of course, that is a self-fulfilling prophecy. If we don't do anything about those abilities, then the likelihood is they're not going to change very much. And so, in a sense, we were right. The students have got a fixed ability. But it doesn't have to be like that, because most of those abilities are developable. And here's why it's worth thinking about. So if we think the abilities are fairly fixed and they don't change over 5 years, then students kind of learn a similar amount each time with the topic. And so their knowledge increases in this linear fashion and they reach the predicted grade. But what if their abilities were somehow developable and you could increase them over time? Then you would find that not a linear graph, but you get this exponential rise with the knowledge and times ability, which is what I called the academic performance. Because the ability is increasing at the same time as the knowledge increase, the graph is going up and the rate of increase is increasing. So that's the contrast. And of course, what that means is that students, if their abilities are actually increasing, are going to get higher grades than those initially predicted. So the challenge, and really the point of mastery, is how can we increase students' abilities? Because if we don't, they'll end up with the grades we predicted, and there hasn't been very much point in putting in all this effort. And the short answer is, you better come to the next webinar if you want to see how we think you can increase abilities. But now with looking at assessment, what we're going to suggest is that a test, which basically can only tell you what's happened with the knowledge, isn't going to be enough. Here's a table to suggest why. So we can do quizzes, like you've seen, and we can assess pretty well whether students have picked up an idea. So that's the knowledge. We can also devise questions to some degree that assess inquiry skills. That's a bit harder. So that's the first type of question. And then we can make long answer questions, more like essays, or, you know, design something, improve an investigation. And again, we can assess inquiry skills. And because there's more openness, then the students can show more of what they are thinking about, and we can find out something about their thinking abilities. Can they see what's important in an experimental situation? Can they argue from a theoretical model? So we get some sense of that ability. And of course, if they have to organize their answer, we can get some idea about their metacognitive abilities. And some of our questions in the AO2 practice books attempt to do that. But it's quite difficult because the space is small and the time is small. And so we're not really looking at abilities. If we want to focus on them, I think we need another kind of task, if you like, an alternative to the test, which is called a performance task, something more realistic, something that gives more opportunity for the students to show their abilities and to show you whether their abilities are improving. So Gemma is going to describe what that looks like. Any questions, Gemma?
Yeah, what about what's the reference source of the 5 factors, which you showed earlier? So the different dimensions of science.
Right. There are millions of them, of course, and we haven't presented that model in detail yet. So all I can say is that if you go back to previous webinars, we've dealt with them individually. So scientific thinking and scientific reasoning are basically how you learn knowledge, how you solve problems. So there's a whole literature on that, but I can't give you a specific reference. There's more than enough on the EEF, the government's website, about metacognition and literacy and mindset. So I think we don't really need to add to that. So basically, these are the categories we've chosen to group all these areas of effects on achievement into. You can choose different names, you can call them different things and have different numbers of categories, but I think all of those abilities are pretty unarguable.
Okay, thank you. Yeah, so I'm going to look at another type of assessment, which is maybe something that you don't do so often, which is a performance assessment. So the whole point of this is giving you another opportunity to assess knowledge and skills, but this time we're doing it in an authentic context. So students are getting some practice at thinking like scientists. And you can use it at the start of the key concept to say this is the problem that you're going to solve at the end, to give them kind of some motivation to why they need to learn that key concept. And also we think that we could have 3 different flavors, if you like, of a performance assessment. So you can have a decision-making one, which is sort of more of the social science aspects. So they are making decisions which have an impact on their lives or the environment. It could be an investigation, so a normal scientific investigation, or it can be a design performance assessment, which is kind of more of an engineering. So they're going to be designing something. It's not a very long project, so we're thinking maybe 1 to 2 lessons. But it's giving you that other opportunity to assess all of those factors that Tony talked about before. So they're having to use all of these this time to do this performance assessment. So you're getting more information on how they're doing science ideas, inquiry skills, which you get a lot of from the tests. But we're also testing those other things as well that are quite difficult to assess in a test. So we're actually starting a new project in September looking at writing some performance assessments. But at the moment, quite a lot of our old activities can be used for this. And this is one that we designed a few years ago called the Chi Wheel. And basically all it is you get this square of paper which you fold up and you put it on a needle, put it on the desk. And if you put your hands underneath it, then the wheel starts to turn. And you can do a bit of showmanship when you show the students this and say, it's the power of the chi energy coming from my hands, and I'm moving this by the power of my mind, and get them to figure out actually, well, that's not true. So what is going on? So they can form their own hypothesis about what could be making the wheel turn round, and then they can test it. So by using this as an assessment, you're testing their science knowledge. So they're going to have to use particle model and density. It's all to do with hot air rising and moving the wheel. They're going to be using inquiry ideas, so hypothesizing. They're going to come up with their own scientific hypothesis. So if they think it is something to do with heat, then they can think up an experiment to test it. So instead of using your hands, they can use some hot water underneath. Does it do the same thing then? Then they can review that hypothesis against evidence. So their evidence is, yes, it does turn around. Therefore, that's backing up my hypothesis. I can explain this using science ideas. We're also assessing their thinking ability. So can they think in an experimental way? Can they come up with an experiment to test a hypothesis? So you can see it's assessing lots of different things. It's assessing their problem solving. It's assessing how well they work with each other to think about ideas. Lots of different things. Now, obviously, some students are going to need more support. They're not just going to be able to come up with this hypothesis and test it themselves. So you can offer different scaffolds. Down the side here, these are the stages from a choir lesson. So if students are used to doing a choir lessons and they're used to those stages and what you have to do at each stage. So you could give them these questions which could help them along the way, which they're used to doing. So engaged, they're always asked, what's the problem here? So they can answer that question. What do they already know that can help? Which is in the enable stage. What do I need to know? What science will solve the problem? Which is from the explore stage. So this is one layer of scaffolding you can give them, these prompt questions. Obviously, there's other layers you can give them as well. Some students might need more help on each of those questions as well. Give them some starting ideas that they can use. And part of the assessment could actually be how much help did they actually need to complete the task. So the outcomes from that performance assessment can give you some information about how well students' problem-solving skills and metacognition is improving. And it also helps you to focus on what skills you maybe need to focus on teaching in more depth. So in that example, if they really struggle to come up with a hypothesis, then you know maybe next time in lesson, you can focus a little bit more on that. Okay.
Thank you, Gemma. Well, we are coming to the end. We just had this extra bonus takeaway, as I called it. I think a few of you have said, yes, you'd like to hear it. Very briefly, we've had some interest from previous webinars about this idea of spaced testing, because clearly one of the big goals is for students to remember everything we taught them over 5 years, and we know that they're going to forget a lot of it. Mastery is about trying to make sure that they learned it really well the first time, so they forget less, but we can't deny the cognitive science. So here is an idea to help you do this, as I know many of you are thinking about how. Quick review: forgetting is a natural thing and happens very quickly, so that if you don't revisit some idea, it's going to disappear from your mind. And what the science says is that if you wait until just before the point where you can't remember it anymore, and you recall it again, you give somebody new exposure to the idea, then that can boost the memory back up again, and you keep doing this at a kind of extended interval rate, and this is the ultimate way to ensure long-term memory. And most language programs now are based on this method. So it does seem sensible to build this into your testing cycle. So here is one way to do this. We are currently revising our tests in our own course. So I'll give you the insight of how we're doing it. So we started off with unit tests. Basically, each key concept has its own test, like Gemma showed you, and you can use those at the end of the unit. You can use those the end of the half term or whenever you want. But now what we're going to do is we're going to use this space testing idea, and we're going to combine the unit test, what you just learned, with certain questions on previous key concepts. Because Blueprint is so specific about what the key concepts are, it's quite easy to do this. So if you're thinking of using Blueprint, this should help you, and we can publish our schedule for retesting if people want that. So let's say we're looking at the first 3 concepts in physics. They are taught at the end of the first unit, forces on materials unit, and because they were learned at slightly different times, what we've got is that this repetition is 21 days after you first learned about balanced and unbalanced, 14 days after you learned about friction, 7 days after density because that was the one that was taught last. I think you get the idea. So then we say, okay, 1 unit later, we do another repetition. We bring a question back about each of those concepts, which means that you've got a second exposure for balanced and unbalanced 56 days after you first learned it. So you've got a kind of doubling, tripling of the length of time, which helps to cement it again in memory. And we have a third edition after about 4 units, which is approximately electric circuits, but it could be some other unit depending on the order you follow. And that's again a rough doubling of the time. So if you built this in, then you would be able to revisit every concept 3 times, which is probably enough, perhaps plus an end of year exam, to keep it well etched into memory over 5 years. So that's the basic idea. Maybe you've already figured that out, but that was what people wanted to know.